Okay, guys, so we're gonna keep going from the last video. If you didn't see it, please watch it. Maybe I will leave a link in the description. So we have this function and this classifier, and we explain how this classifier works, and we classify everything related to that. Now we were asked doing something similar, giving we have g1 equal 1, g2 equal 0, and g3 equal 1 to classify this with Naïve Bayesian. So what Naïve Bayes does is assume there is independent between g1, g2, and g3 values. Okay, we assume they are independent, so this is the basic assumption. And then what we are getting is this formula. This formula means that what we want to know if, for example, the person is sick or not, the hypothesis that the h is for some value v, given a vector x, is with a Bayes theorem is p of h equal v times p of x given h equal v divided by p of x. Okay, so in other words, it means the posterior probability, so this one, equal the prior probability, which is this one, times the likelihood that this event actually occurs, divided by the evidence, okay? The amount of vectors we have with this formula. Anyway, so because the independence, we get that p of x given h is actually v, is the multiplication of each xi given h equal to v. So in our case, when we get a vector x and h, for example, whatever v, we are doing the probability that g of 1 is x1 times the given h equal to v, and times p of g2 equal to x2 given h equal to v, and the same for g3 and h equal to v. So now we're going to start the calculation for everyone giving this table. This is the value we want to predict, okay, the y value. So let's start the calculation. So just to be clear, h, y is the h. Okay, the hypothesis. Okay, so how many rows do we have where h is actually plus? We can count it 1, 2, 3, okay? And how many rows do we have? It's 1, 2, 3, 4, 5, 6, okay? So we have 1 divided by 2, so it's a half probability to be plus, okay? And with no information given. Now, we want to calculate, given h is plus, what is the probability that g1 equal to 0? Okay, so how we are gonna do it? We're gonna first look only on these rows where h is plus, and then at all the rows where g1 is 0, which we have only 1. Okay, so this row, so meaning it's 1 divided by 3. So, okay, clear? Okay, now given that g1 is 1, okay, given h is plus, and what is the probability that g1 is 1? So again, we're looking only on these 3 rows, and now we will count. We have 1 and 2 rows where g1 is 1 and y is actually plus, our h. Anyway, so now it's 2 divided by 3. And given that h is plus, what is the probability that j1 is 2? We can do the same, but when we see that this sum is already 1, meaning this have to be 0. Okay, now we'll go over this one pretty quick. Given that h is minus, okay, so our y rows are this one, and this one, what is the probability that j is 0? Okay, so again, these are the rows. Okay, so what is the probability that j is 0? So we have only this row for what I can see. G2, sorry, we're looking at G2. So here G2 is 0, and here G2 is also 0, but here is 1. So how many rows does... Oh, shoot. I looked at this first, because I selected these rows. So my bad, hope you forgive me. But we'll go over this again, because I made a mistake. It's a really long process. Anyway, so let's look at this. We have h equal to plus, meaning this row, we have this row, and the last row. Okay, and how many of them have g2 equal to 0? Here g2 does not equal to 0, here g2 does not equal to 0, and here g2 does not equal to 0, meaning it's 0 divided by 3. But how many of the rows does g2 equal to 1? It's exactly all the rows. Okay, we can look at this row, and this row all have plus in the y, but and have g2 equal to 1. Okay, now this we already saw, and we will do this one. So how many rows? It's these 3 rows have h equal to minus, and how many of them does have g2 equal to 1? We can count. It's only one row. It's 1 divided by 3. Okay? Now, we will do this one and this one, just, to save some time. So h equal to plus, okay, and g3 is 0. So this row, this row, this row, and this row, and g3 is 0. Okay, it's only one row. Okay, so it's 2 rows. Almost missed it, meaning it's 2 divided by 3. And here we can see it's only 1 row, so this is 1 divided by 3. And now let's do this. So h is minus, meaning it's this row, and this row. And we want g3 to equal 1. How many rows do we have? It's only one row, right? It's this row and this row, meaning it's 2 rows. So it's 2 divided by 3, and we have 1 row of 0, meaning this is third, and this is 2 divided by 3. Okay. Now we need to start writing each probability. So the probability, according to this formula, yeah? So we have P of h equal to plus times the probability that h equal plus given 1, 0, 1 equal the probability of h equal to plus, this one, times P of g1 equal to plus given h equal to plus, and here we can just look at the values we already got. So this, this is the value, okay, g equal 1 and h is plus. Now g2 is 0, okay, and h is plus, which is 0. Okay, so we already know that the result will be 0 because it's all multiplication, but we're gonna do this anyway. So g3 equal 1 and h is plus. So g3 is here. Okay, and now we get 0, and here we're doing the same thing. H minus is half, which is this one. G1 equal 1 and h is minus. So g1 is 1 and h is minus. We can look here. G2 is 0 given h is minus. So g2 is 0 given h is minus. So it's 2/3. We can see it here. And g1 is 1 given h is minus. Given. It's a lot of calculations. Okay, and then when I put it in my calculator, we get 4 divided by 27. So it's pretty obvious that already now we're going to classify this as minus. Okay, so we don't really need to calculate it, but in case you want to, you can. Okay, so this is the question. I hope you like this video, but just to be clear, we're gonna classify h as negative. Okay, meaning we're gonna said with naive Bayesian that y is negative. Okay, meaning the person is not sick. Okay, because by the way, if you look, this is the same row. Okay, oh, it makes sense. Anyway, hope you like this video. Please subscribe to my channel, and until next time, I'm out.